Hello everyone, today in this video we'll be discussing the fourth module of CN super important questions. In this module we have 7 super important questions from the model paper as well as in the previous years and previous scheme papers. Make sure you watch this video till the end. I easily can score more than 80% marks, and before starting please to like and subscribe. It helps me make more videos like this, and without wasting any more time, let's get started. The first question is list and explain the services provided by transport layer. Okay, so this question you need to understand very well. They have not asked about the TCP. Okay, there can be two questions here. Both the questions are there in this video. This is about the transport layer. Okay, inside the transport layer there is a protocol that is called as TCP. Okay, and the services provided by them are different. Okay, so this is related to transport layer. So there are 5 services provided by the transport layer. Okay, the first one is very important: process to process communication. Okay, the next one is encapsulation and decapsulation. Third one is multiplexing and demultiplexing. Fourth is flow and error control, and fifth is congestion control. Okay, so what is process to process communication? See, process means what? Some task which is running. Okay, in the sender side also some task will be running, and in the receiver side also some task will be running. Now the process will be in one computer. In one computer the process will be running. This also process will be running in one computer. The computers are connected at network layer. Okay, the computers are connected at network layer. The process is connected at transport layer. Okay, so the transport layer's job is to make a connection between these two processes. Okay, so that's what it will be doing. The first duty of transport layer protocol is to provide process to process communication. A network layer protocol can deliver messages only to the destination computer. Okay, network layer, what it will do, it will send to the computer. Okay, it will not send to the process, but it is still an incomplete delivery because computer it is sent, but to the process it is not sent. The message still needs to be handed to the correct process. Here comes the transport layer, which is responsible for delivering the message to the appropriate process. You got the point? Now this is the diagram here. This is the client computer, server computer, and the network layer connects these two. Okay, and inside this whatever the processes are going on, the processes are connected at the transport layer. Okay, so this is the first application of transport layer, process to process communication. Very important question. Okay, it is there in the model paper also. Encapsulation and decapsulation is the second one. Encapsulation means what? See, if this is one thing, encapsulating means covering it. Okay, covering it with some other data. That is encapsulation. Decapsulation means removing this cover and taking out the data. Okay, that is decapsulation. To send a message from one process to another, the transport layer protocol encapsulates. Okay, what it does, it encapsulates the data, and at the receiver end it decapsulates the data. Encapsulation happens at the sender side. Headers are added before sending the data, and decapsulation happens at the receiver side. Header is dropped and the packet is delivered by the transport layer to the process running at the application layer. Okay, so adding of header. Okay, adding header is called as encapsulation. Removing the header is called as decapsulation. Okay, so this is the diagram here. Here the process and the message is there, and once the header is added it is encapsulated. That encapsulation will be encapsulated data will be sent here, and that header will be removed, and here we will be getting the actual data. Okay, so that is encapsulation and decapsulation. Next one is multiplexing and demultiplexing. What do you mean by multiplexing? Multi means, just remember, multiple, from one to many. Okay, whenever an entity accepts items from more than one source, it is called as multiplexing. If more than one source are there and it is sending data to one source, that is called as multiplexing. When an entity delivers item to more than one source is called as demultiplexing. So when it is delivering, okay, if the direction is like this it is called as demultiplexing. If the direction is like this it is called as multiplexing. Okay, next is flow and error control. What is flow control? Flow control means, see, suppose that there is a biscuit manufacturer. Okay, there is a biscuit manufacturer and it produces 100 biscuits in a day, but in a particular box only 50 can be accommodated at one time. So if 100 are produced and 50 only can be accommodated, the remaining 50 will be lost, right? So that flow control should be there. At a time only 50 should be sent. When the box is empty again, another 50 should be sent. So that is called as flow control. Like that only, when sender sends the packets, how much receiver can receive, that only, that many only packets should be sent. Otherwise some packets will be lost. Okay, that is called as flow control. Flow control is needed when producer is producing more than consumer can consume. Okay, producer is producing more than consumer can consume. So there are two ways in which we can uh, in which the consumer consumes. Okay, two ways. First is sender is pushing the packets. Sender is sending the packets, so consumer will consume it. Second is receiver is requesting the packets. Okay, receiver is requesting the packets. That is the second way of getting the packet. Okay, so here the diagram is given. This is the sender side, this is the receiver side. Here the producer is sending the messages to the consumer from the application layer to the transport layer, and here a flow control should be there. How many the consumer can handle, that many only should be sent. Next, after that, the packets are pushed to the consumer at the transport layer, and here also the control should be there. How much this is sending, how many packets this is being sent to the consumer at the transport layer at the receiver side, that also flow control should be there. After that, the producer will take it from the consumer, and from here the messages are pulled to the consumer at the application layer. Okay, so two places flow control should be there. One is between application and transport layer, another is between the transport layer of sender and receiver. Okay, so buffers are used for that, means for storing the data. Okay, for storing the data, buffers are used. Buffer is like a box. Inside the box, packets will be there. Okay, error control is needed in the following cases. There are four places where we need error control. What do you mean by error control? If any wrong packet has arrived, we have to discard it. How do we do that? Detecting and discarding the corrupt packets. The first place where error control is needed is whenever a corrupt packet has come, we have to detect and discard it. Second, keep track of lost and discarded packets and resending them. Okay. Third is recognizing the duplicate packets and resending them. Fourth is buffering out of order packets until the missing packets arrive. If the packets I have sent was 123, it has arrived at 213. So this has to be discarded. It should be arrived in the same order 123. Otherwise, the data's meaning will be changed. Okay. So these are the four cases where error control is needed. Okay. Also, we use the sequence numbers and acknowledgement numbers for the error control. Packets are numbered sequentially, like 1, 2, 3, 4, 5, and combining flow and error control gives a sliding window protocol. This will be discussing in the upcoming questions. Okay, so combining the flow and error control, will get a protocol which can be used for handling both together. Okay, last is congestion control. What do you mean by congestion? Congestion means, see, the normal language also, what does congestion mean? Congestion means a lot of things together coming, right? This is called as congestion. So it can happen when a network when number of packets sent to a network. Okay, how many packets that are being sent to the network, it is more than how many the network can handle. If network can handle only 10 and I'm sending 20, that means there will be congestion. Okay, so to handle congestion, congestion control mechanism is used. Okay, so the transport layer uses that by using the TCP. Okay, this also another question is there. We'll be discussing the TCP congestion control mechanisms. Okay, so that was about the first question. Moving on to the second one, super important question, which is explain all the fields in TCP segment. Okay, in TCP segment we have some fields. Okay, so the first thing you have to draw is the segment part here. In the segment we have two parts, header and the data. Okay, now inside the header, this is there. Okay, this is the whole thing is coming under the header. So in the header we have the source port address. What does that means is which port the data is coming out from. That is called as source port address. Destination port address, from to which port it is going to. Sequence number is the one which packet we sent. Okay, suppose that we send the first packet, the sequence number will be 1. Second packet, the sequence number will be 2, and so on. Now these packets will be received at the receiver end, and receiver will be sending acknowledgements back. Now when the acknowledgement is sent, for the packet 1, acknowledgement will be 1. For the packet 2, acknowledgement will be 2. Okay, ACK2, and so on. So that is acknowledgement number here. Both are 32 bits. After that we have h line, which is header length. What is the length of the header? Between 20 to 60 bytes, whatever it is there, that will be stored here. After that, reserved 6 bits are there, and here the window size is there. What is the window size? Means at a time how many packets can be sent. If window size is 5 packets can be sent at a time. Okay, and urgent pointer is used for storing urgent data. Okay, so and options are pending will have some optional data which we'll discuss. Now here 6 bits are there. Okay, control flags are there. Let's have a look. What are those control flags? So the same thing which I explained, that is there in the theory part also. You can go through this. And so what are the control bits? Okay, control bits, first is URG. URG means urgent pointer. Okay, ACK means acknowledgement. PSH means request for pushing. RST means reset the connection. SYN means synchronize the sequence numbers. Means whenever we send a packet, SYN will be used. Okay, whenever we send the packet, SYN will be used. And FIN is used to terminate the connection. FIN means finish, terminate the connection. Okay, the same thing here. The window size checksum. Checksum is nothing but it is a number which is calculated based on the data which we have, and it ensures that it is used for testing if the data is fine or not. Okay, means from the sender side one data was sent, in the receiver side is that same data received or some corruption has happened, that will be identified and detected if you use the checksum. Okay. That was about the second question, TCP segment fields. Let's move on to the third question, UDP segment fields. So in the UDP segment fields, we have to, it's very simple here. This is a very small diagram. Also, we have to explain UDP checksum with an example. Okay, now I'll be discussing how checksum is calculated. Okay, with an example. Now, in user datagram format, the header is of 8 bytes and the data is of 8 bytes, 8 to 65535 bytes. Okay, that is the size of the data. So two things are there, header and data. And inside the header, we have four more things, which is source port number from where the data is being sent, destination port number where the data is being received, total length denotes what is the total length of the header and the data, and checksum is nothing but the value which we have for detecting if there was corruption or not. Okay, now let's understand checksum using an example. Suppose that the numbers to be sent are 7, 11, 12, 0 and 6. Okay, so to calculate checksum, first calculate the sum. What is 7 plus 11? 18. 18 plus 12 is 30. 30 plus 0 is 30. 30 plus 6 is 36. So I've got the value of the sum as 36. Now 36 in binary is 100, 100. Now the sum is in 6 bits. As you can see, there are 6 bits here, but each of this number is of only 4 bits, right? So we have to reduce 6 bits to 4 bits. How do we do that? To reduce 6 bits to 4 bits, what we will be doing is we will be dividing this into two parts, the leftmost two parts and the rightmost four parts. Okay, now 1 0 will be taking it separately and 0 1 0 0 will be taking it separately. Then we'll be adding it up and we'll be getting one answer. This is in 4 bits, right? So this is the method which we use to convert 6 bits into 4 bits. Okay, you can take the same example in the exam as well. Okay, now we have got 6. 6 is the answer, which is checksum. Okay, you got the point how we calculate checksum. First calculate sum and reduce the bits by using this algorithm, and we'll be getting one checksum. Now this checksum is added into the data and it is sent. Now what happens when this data is received at the receiver's end? If any corruption has happened, like for example 12 has become 13, if 12 has become 13, the sum of all the numbers which we have here will be 37. 37 will not be equal to 6, right? 6 we have sent here, the checksum. 37, when we use the algorithm, like this algorithm, and find out, it might come as 7 maybe. So when we got it as 7 and the last thing which we had put here is 6, and we have got the answer here as 7 because of 13 here. At that case, 7 and 6 does not match. We can detect that there was a corruption. Got the point? So this is how the UDC checksum works. Okay, in UDP, if we are adding a checksum, we have to add pseudo header. Okay, what we have to add? Pseudo header. Pseudo header, here we having here we have the source IP address. Here we have the destination IP address, and here we have three fields, all zeros, 8-bit protocol, and 16-bit UDP length. And here checksum is provided. Okay. So this is the pseudo header. You're not making the exam. You just have to explain what is checksum by using an example just like this one. Okay. So moving on to the fourth super important question, which is explain stop and wait and selective repeat protocol. Okay, two protocols we have to explain here. What is stop and wait, and we have to also include the FSM diagram. Okay, whenever the protocols are asked, like stop and wait, go back, and selective repeat, we have to include the FSMs also. Okay, so let's understand how to remember the FSM and what does this protocol mean. Stop and wait. What do you mean by stop and wait? Stop means stop doing whatever you are doing, and wait means wait for some time. Stop and wait protocol is a connection oriented protocol. It uses both flow and error control. Both at the sender and the receiver use a sliding window of size 1. So here, since flow and error control came together, we'll be using the sliding window as well. Okay, after FSM I'll be explaining you with an example what does sliding window do. Okay, so to make this diagram you have to make first two things. First is sender and second is receiver. In the sender, make two parts, ready and blocking. Okay, two are there in sender, ready and blocking, whereas in the receiver only one is there, ready. Now in the ready part, what you have to do is first just focus on the blue part. Request came from the application. When request comes from the application, send a packet, a packet is sent. Whenever a packet is sent, it will come to the blocking phase and it will wait here. Okay, it will wait. It will not send another packet soon after sending the first packet, but it will wait. In waiting, two things can happen. First thing is timeout can happen. Waiting, acknowledgement is not received back. See, when we send a request, at if it is received in the receiver's end, our acknowledgement will be sent back. If it is not sent back, restart the timer and resend the packet. If an acknowledgement is received but it is a fake acknowledgement or corrupted acknowledgement, discard the ACK and keep on waiting and resend the packet. Okay, in case we have received an acknowledgement which is correct one, at that case we will be moving on and coming back to ready to send the next packet. Okay, so this is about the senders end. In the receivers end, if we are in the ready phase, three things can happen. First thing is corrupt packet has arrived. When we had sent a packet, that packet, some hacker came and made some changes, so the packet became wrong. When the wrong packet it became, we have to discard that packet. When the wrong packet comes to the receiver, we have to discard the packet and wait till the correct packet comes. In case the correct packet comes, we have to take that correct packet and send the acknowledgement. In case the error free packet has come, the correct packet has come, but which we are expecting, that packet has not come, some old packet came. Okay, if an old packet came or a duplicate packet came which we had already had, suppose we already had the packet number 4 and packet number 5, another new packet came and guess what, it was packet 4 only. So this is, in this case, the packet is duplicate, so we have to just discard it. Okay, and send acknowledgement with what we have till now. Okay, so that the latest packet will be sent. Okay, so this is the FSM diagram we need to make. Let's understand now using a simple scenario. Here acknowledgement and sequence numbers are used to keep track of the packets. Okay, these two numbers are the sequence and acknowledgement number. So first thing you need to make is sender and receiver, just make a straight line like this. Okay, after that there are timers here. Okay, and also here is the window, this is the sliding window, one for the sender, one for the receiver. Now there is packet 0 1 0 1 0 1 which is to be sent here. Okay, now what happens, first packet 0 will be sent and the timer will be started. Okay, packet 0 will go here and it will be received here. Once it is received here, it will send the acknowledgement 1. Acknowledgement 1 will be sent because next it requires the packet 1. So whatever the next packet is required, that acknowledgement will be sent. Now acknowledgement will be arrived here and sender will see which is the next one, 1. So next 1 will be sent. Now 1 was going but it was lost here, or some hacker came and stopped the data. So when the packet is lost, it will not be received here. So when it will not be received here, there will be no acknowledgement sent back. When there is no acknowledgement sent back, the timer will be out. Timer will be out and restart will happen. Restart means packet 1 will be resent again. Packet 1 is resent again, it is received. Next packet it requires is 0, so acknowledgement 0 will be sent back. And acknowledgement is also received here. The acknowledgement 0, I mean the acknowledgement 0 is received, so it will be sending the packet 0 here. The packet 0 is sent and it's received. The acknowledgement means the packet 0 is received. Next is 1 here, so 1 will be it will send the acknowledgement for 1, but here in this case acknowledgement was lost. Whenever the acknowledgement is lost, in that case acknowledgement is not received here. This the sender will think if acknowledgement is not received, the packet was lost in between. It will assume by default that one. Okay, so it will resend the packet 0. Okay, packet 0 will be resent. When packet 0 is resent here, in that case it will get the packet 0 again. It had already got packet 0, it had sent the acknowledgement also, but again it received the packet 0, so it will discard the duplicate packet and again it will send the acknowledgement 1 that it requires the first packet. So it will come here and from here it will again send the packet 1. Okay, so this is how the stop and wait protocol works. Okay, moving on to the selective repeat protocol. Okay, in selective repeat, as its name implies, sending only those packets that are lost. We only will send those packets which has been lost. Okay, so let's understand how does that happen. The track of lost packets is kept. Okay, to send the lost packets, we need to know which are the lost packets. So a track of lost packets needs to be kept. How is that kept? It is kept via the received acknowledgement numbers. See, suppose that I send 1, 2, 3, 4 and I received acknowledgement for 2 and 3 only. Tell me which is the lost packet. Lost packet is 1 and 4, right? So in that way we calculate which is the last packet and we keep track of it and we'll resend it after the timeout. Okay, So the selective repeat works as follows. See here, there is one window here and there is another window here. Okay, this is sender window, this is the receiver window. Now in the sender's window, we have a sliding window, means 4 packets can be sent at a time, after which it will recheck if any other packet, if any other acknowledgement was not received, it will resend that packet. Okay, as we go through the diagram, you'll get to know what I'm trying to say. First is packet 0 is sent here. Okay, now packet 0 is sent here, it is received packet, packet 0 is also received here, so packet 1 will be sent. Okay, packet once, see, packet 0 is sent here, acknowledgement 0 only will be coming. Okay, unlike the previous one where acknowledgement 1 used to come, right? Here the same acknowledgement will come. Okay, this is another protocol, selective repeat. So here the same acknowledgement will come. So acknowledgement 0 has come. Once acknowledgement 0 has come, means this packet is successfully received. Next is 1 is sent, 1 is lost here. So since 1 is lost, the acknowledgement does not come, but it will not wait for that acknowledgement, it will send the next packet, which is 2 is sent, acknowledgement is come for 2. Next 3 is there, 3 is sent, acknowledgement is come for 3. 4 is sent, 4 is not sent. Before sending the 4, it will recheck the packet if any other packet has been sent or not. What I mean is, any other packet sent or not means the packet which was sent but acknowledgement was not received. Packet 1 was sent but acknowledgement was not received. Like those packets will be checked. Okay, and that will be pointed out by SF here. Okay, so 1 was sent but acknowledgement 1 was not received, so it will be resent here. After resending it, it will means send back the acknowledgement after receiving it here. And once 1 is received here, it will shift the whole window to the next ones, means 4 5 6 7 needs to be sent after this, right? So since 1 2 3 was means 2 and 3 was already sent, and now 1 is also sent, means 1 2 3 is done. It should, the sliding window will shift 3 places to the right, so 4 5 6 7 will be into the consideration now. Okay, so whenever the timeout happens, this thing will be rechecking. Okay, see, till here only 2 packets were sent, 2 and 3, right? 2 and 3 was sent, 1 was sent but acknowledgement was not received, 1 was lost here. So the timeout happened. Whenever timeout happens, it will recheck which all packets acknowledgement I have received. I have received for 2 acknowledgement, I have received for 3 acknowledgement, I have not received for 1 acknowledgement. So whichever I have not received, that I will reset. Got the point? And after resending it, again the timer will start and the sliding window will slide, and all those things continue to happen. Okay, so this is an example scenario of selective repeat. Here we are just selectively sending that only which are lost. So here duplicate packets will never come. Okay, duplicate packets will never come. Okay, this is updated version of go backend protocol, another protocol. Okay, so here both center and receiver window are used. FSM diagram for MESA protocol. Okay, so you need to understand this very carefully. Okay, so see here. Okay, see, sender is here and this is the receiver. First let's understand the sender. Sender, as I told you, two states are there, ready state and blocking state. Okay, so in ready state, what happens? The first thing, request came from the process, send the packet. While sending the packet, we have to check if the window is full or not. If the window is not full, don't send. Send it and again come to the ready state. Okay, until the window is full, we will be keep on sending. Okay, so we'll check window is not full, come back. Window is not full, come back. Sending and coming back, sending and coming back. This will repeat until window becomes full. Once window becomes full, we have to come into the blocking state and wait. Wait for what? Wait for the acknowledgements and wait for the timeout to happen. If timeout happens and there are some packets for which we have not received the acknowledgement, we'll resend those packets and reset the timer. In case we have sent the packets and acknowledgement we have received is corrupted, so we'll discard the acknowledgement and wait for the correct acknowledgement. Okay, in these two cases we will wait. In case the window slides, okay, window slides means the window has shifted, all the packets which were there in the window have been successfully sent and the window is sliding, we'll come back to the ready state. Window sliding means I have new packets to send. If the window is not sliding, means I have to stay in the same state. Okay, and if error free acknowledgement has come or the corrupted acknowledgement has come, in both cases stay in the blocking as well as ready state. Okay, just have to write the blue ones in the exam. Okay, in the receiver side we just have one state and three possibilities are there. Corrupt packet has arrived, discard the packet. Error free packet has arrived, discard the packet if it is a duplicate packet. But if it is a correct packet, then take that packet and send the acknowledgement to the sender's side. Okay, this was about the stop and wait as well as selective repeat protocol. Okay, Moving on to the fifth question, super important question, explain the connection establishment using three-way handshaking in TCP. Okay, so in this question they just have asked connection establishment. Okay, but they can even ask you the connection establishment, data transfer, as well as connection termination phase. Okay, three things are there. Okay, see, in TCP, connection oriented transmission requires three phases. First is connection establishment, second is data transfer, third is connection termination. So in case they ask you about the data transfer or the connection termination as also, that in that case you should be ready with the answer, right? So I have included all of them here. So it's very simple, there is nothing much difficult. The same process is getting repeated with the some slight differences. So let's understand each one by one. So what happens, this is the sender, this is the receiver, this is the client, and this is the server. Okay, now from the client to the server, you have to get a connection. Okay, so see here, connection establishment means what? Establishing the connection before sending a request. Okay, before transferring the data. Okay, before transferring the data, a connection has to be established. So to establish a connection, we use a protocol called as three-way handshake protocol. Okay, in connection establishment in TCP, the first step we will be using three-way handshake protocol. So what happens in three-way handshake protocol? Client sends a request for starting a connection. Okay, see, client is sitting here, it will send a request. Okay, it will send a request to whom? To server it will send, saying what? I want to start a connection. Okay, by using SYN. Okay, synchronized sequence bit it will be sending. Okay, this denotes that client wants to start a connection. After that, server will send back SYN plus ACK acknowledgement, acknowledging that you can send the request. Okay, so server is ready now, and after that client sends an acknowledgement back to the server implying that the connection will be beginning very soon. Okay, so there is a three-way handshake protocol here. First, client is requesting, second, server is confirming, third, client is also confirming. Okay, here is the diagram. Okay, you just have to make a very basic diagram. Just write client here. Okay, just write client here, and after that make a line and send here as the first as request plus I mean syn plus ACK, and here ACK, and here you make a server and a line. Okay, that means also and from the exam point of view. Okay, so here the same thing is depicted in diagram. After this, the data transfer phase. Once connection is established, data can be transferred. Also, bidirectional data is there. That means both sending and receiving can happen at the same time. Okay, that is called as bidirectional. The client and server can send data and acknowledgement in both directions. The following diagram illustrates the data transfer phase. Okay, first the request is sent here, it is received here. Another request is sent, it is received here. The server has sent back the answer. Another request is coming here. Like that, the data will be exchanged. Okay, data will be what exchanged between the server and the client, and then after all the data is exchanged, the connection will be terminated. Okay, so in connection termination also it follows the three-way handshake protocol. So what happens? First, the client sends a FIN message. FIN means finish. Client sends FIN to server. Server will see client wants to end the data transfer. So FIN it takes and sends back FIN plus ACK, confirming that you can end the data connection. So client sends ACK back after terminating the connection. Okay. So the below diagram depicts the same. FIN from here, FIN plus ACK, and ACK from here. Okay. Moving on to the sixth super important question, list and explain the services provided by TCP. The first question was what? The first question was the transport layer. Okay. The services provided by transport layer. This question is provided by TCP. Don't confuse between them. Okay. I'm repeating, don't confuse between them. You can lose marks if you confuse. Okay. So there are 6 services provided by TCP. The first is process to process communication. Here what happens? The TCP provides process to process communication using the port numbers. So how it provides? By using the port numbers. So it sends a packet not only to the destination computer, but it also ensures that it is delivered to the process that has requested it. Okay, means this is the destination computer. Inside the computer there will be one process. So TCP will ensure that not only in the computer but to the process it is getting delivered. Okay, that is the first service of the TCP service, process to process communication. Second is stream delivery service. Stream delivery service means what? It allows sending the process to deliver data as stream of bytes. Okay, means a continuous stream of byte. It allows sending the data. And third one is full duplex communication. Full duplex means it is sending as well as receiving the data at the same time. Okay, multiplexing and demultiplexing, TCP performs both of them at the one at the sender side multiplexing, and second demultiplexing at the receiver side. The fifth one is connection oriented service. Three-way handshaking is used before sending some data so that a secure connection is established. And the last one is reliable service. TCP is a reliable transport protocol because it uses the acknowledgement and the sequence numbers and the error and flow control, and it is a secure algorithm because it uses connection oriented service. Three-way handshaking is done, so it is a reliable service. Okay, so the data whichever is being sent is safe and sound in through the TCP. Okay, that was about the six services of TCP. Moving on to the last question, super important one. Explain the congestion handling policies of TCP. Okay, how does TCP handle congestion policies? Congestion means what? A lot of packets have come into the network and network is stopped. Okay, so how to avoid this one? To avoid this one, there is three things. Okay, the first thing is three algorithms are there. First is slow start, second is congestion avoidance, third is fast recovery. So slow start, what happens? In slow start, the algorithm starts with one size, means one packet is sent. After one packet is sent, it will receive one packet. So whenever it receives one packet, it will add that to the limit. Okay, means one packet was the limit sending. Now one acknowledgement is received, so it will add it to this one. So next time it will send two packets. When it send two packets, two acknowledgement will be received. When it receive two acknowledgement, it will add up to this one. So next time it will send four packets. Like that, it will keep on going 4, 8, 16, 32, 64, and so on. Like that, it will keep on exponentially increasing. It will start slow, but it will exponentially increase. In this diagram, you can see it is starting very slowly, but it is exponentially increasing. Okay, 2, 4, 6, 2, 4, 8, and so on. This is the slow start and exponential increase. Now, if it's exponentially increasing, it will very soon cause congestion there, right? Because it will have sending very high amounts of packets in very small amount of time. To control that, we'll be using the second one, which is congestion avoidance. It is additive increase. So whenever a large number of packets are being sent more than the capacity of the network, the exponential increase will stop and additive increase will happen. Which means if suppose two were sent, two were received here, and four were sent, and it caused a congestion. So next time 4 will not be sent, 5 will be sent, 6 will be sent, 7 will be sent. Instead of 4, 8, 16, 4, 5, 6, 7, 8 will be sent like this one. Okay, slowly it will be sent. That is the additive increase. Okay, so it slows down the congestion. Okay, and fast recovery is an algorithm optional in TCP. It is used in newer TCPs. So it starts when duplicate acknowledgements arrive. Okay, when does fast recovery start? Whenever a duplicate acknowledgement is arrived. So it is same as congestion avoidance, where the additive increase will happen. See, first exponentially it will increase. Once congestion is encountered, it will start increasing additively. Once it starts increasing additively, it can either be congestion avoidance algorithm or fast recovery algorithm. That depends. If duplicate packet is received, fast recovery will be used. If the duplicate packets are not received, but the normal packet acknowledgements are received, corrupted ones, and so on, in that case the congestion avoidance will be used. Okay, so this is about the congestion control policies in TCP. This is all you have to make, and make sure you solve all these questions. Very important one from the exam point of view. Don't miss any of them, and please do like and subscribe. It has been more videos like this, and thank you so much for watching. I'll see you in the next one.